Hey everybody, in this series of videos, we will be going over the independent samples t-test, which is what we use for comparing means or averages. The PDF that I'll be using is provided in the assignment instructions. All right, so let's get started. The independent samples t-test tells whether two groups differ on variables measured at the interval or ratio level of measurement. So what this tells us is that we use the independent samples t-test for a group comparison type research questions. And because we're dealing with means or averages, the variables have to be numeric. And so they have to be interval or ratio. And then the last part about that sentence right here is it's for two groups. If we have more than two, then we would have to use a different type of statistical test. Now, this test is good for marketing context because we compare two market segments a lot. And then there's also A/B testing, where, for example, we might use a different font or a different text color or a different image on a website or a web page, and we see how those pages do or how those ads do depending on what we use. And then really it's useful for any other time when we want to compare two means. So again, just two different groups. A few examples. Perhaps your company serves large and small clients, and you want to see if each group is satisfied with the service that your company offers. So you might want to compare the satisfaction levels there, and then in a sales context, and then also the topic of remote work. You might be interested to see if your inside sales reps are more productive versus those who work remotely. And then for the rest of our videos, this will be the example that we will be working through. Who purchases more coffee from coffee bars or shops? Young professionals or mature professionals? So all these different questions listed here, those are group differences research questions. So let's look at our problem, our example problem, more closely. In developing promotional media for your small chain of coffee shops, you want to know whether you should use young professionals or more mature professionals in the media images. Both of these groups frequent your coffee shops, but you don't know which group is the heavier consumer of coffee beverages in your town. You survey a random sample of 450 professionals, asking how often they purchase coffee at a coffee shop. And here are the results. So let's unpack this. For this part here, the part where it says X bar, that would be the mean in the sample. And really, you could make the subscript anything. In this case, we use Y to signify the young professionals. So the sample mean for young professionals is 5.05 purchases compared to 4.23 purchases per week when it comes to the mature professionals. And just looking at that, you might think, oh, it looks like young professionals purchase more compared to mature professionals. But we don't want to jump to conclusions, right? Right? Number one, we don't care what the sample says because samples lie. Jumping down here real quick, the fundamental statistical question is when it comes to differences or what we see in the sample, is it because of noise? Is it because of sampling error? Or is it because there really is a difference? And that's what this statistical test will help us determine. All right, so before I move on to the next topic, let me remind you what these other two are. So we have S, which would be the sample standard deviation, and then N, would be the sample size. And just like all the other types of statistical tests, we have assumptions and requirements that we have to meet. Number one, the analysis variable, sometimes called the dependent variable, is measured at the interval or ratio level of measurement. So we already talked about that. As far as how in our example, we're looking at means or averages, so they have to be numerical. And then number two, the grouping variable, sometimes called the independent variable, consists of two independent groups that are mutually exclusive. That is, a person in your sample can belong to only one group, and that would be the case in our example. We have people who are either a young, or would be in the young professionals group or the mature professionals group. Number three, there are no notable or influential outliers. The smaller the sample size, the easier it is for an outlier to be influential. And if you recall, the way we find outliers would be we use a z-score. And then number four, the analysis variable is approximately normally distributed for each group in your analysis. So that means that both groups should have a normal distribution. And really, when it comes to the t-test, so as I put here, the t-test is reasonably robust. So what that means is that it would still be pretty accurate even if it wasn't quite meeting this requirement. And when it comes to data that we collect, that's usually going to be the case. It's not going to be perfectly normally distributed. And so we're going to be looking for the following conditions in this case. So the two groups are approximately equal in size. And so if we look at our example, they're pretty close, 208 versus 242. And then if there is skew, it would be in the same direction. So whether that's positive or negative, it would be the same. And then, what else is there? And approximately the same size, not extreme. And then the sample size is larger than 5 per group. Now, when it comes to marketing context, typically we're not we're not just gonna do 5 as far as the sample size. Typically, that's not what's gonna happen. We will have more than that. And the thing about number 3, number 4, and number 5, which I'll talk about in a second, we have software that will determine this for us. So it's just good to know that we're meeting these different conditions, these assumptions and requirements. All right, number 5, the variance in the two groups are approximately equal. So variance, if you recall, would be the distribution of your data. Is it spread out or is it closer? So if it's spread out, then we consider that a large variance. If it's closer together in clusters, then that would be small. And it doesn't matter in the t-test whether it's big or small. They just have to be approximately equal. And really, this one's not a big deal either, because if that's not the case, we can do something else. And oh, that reminds me, if for whatever reason number 4 is not met, so this requirement here, then there are things we can do, but that's more for advanced statistics, which we're not going to do in this class. And really what that means then is, in this learning environment, well, pretty much the examples I'm going to give you or the different exercises that you'll work with, these assumptions will be met. So there is that also. Okay, number 5. So this condition here is what we call the equality or homogeneity of variances assumption. Okay, so assuming that we have met all those 5 requirements for this example problem, then we can move forward. The next thing we need to consider is as with any hypothesis tests, we have degrees of freedom and then our confidence level. And again, we're not going to care about the degrees of freedom or any kind of formulas because our statistical software will do that for us. But just so you know, in this case, when we're comparing 2 groups, this would be the formula. So sample 1 minus 1 plus sample size 2 minus 1. So in our example, that would be 448. And all our examples in our class will be working in the 95% confidence level, so that gives us an alpha of 0.05. All right, so the last thing I want to talk about in this video is our hypothesis test. So our null hypothesis is that the mu, so if you recall, mu is the symbol we use for the mean or average. So what we're saying here is mu sub y, or young professionals, is equal to mu sub m, so mature professionals. The mean purchases for the 2 groups do not differ, hence the equality. Another way to put this, so let me type this in, is in the population, young and mature professionals make the same number of coffee purchases and then our alternative would be that they differ, so we have that inequality sign. All right, in the next video, let's continue with the formula for T.